Well, hello friends. Welcome back to the program. Today we are going to play another round of the FIXME Roulette because we have been getting a lot of things done this way and it's a lot of fun. So let's keep it going. So if this is your first time here, what we do is we just git grep for FIXME or to-do in the Serenity codebase. And then we pipe that to ShuffN1 so that we get one FIXME or to-do to deal with. And then we try to deal with it or at least make some kind of progress. So today's task is going to be, click, in Path2D.cpp to do implement constructing Path2D object with SVG path string. All right, so in Path2D.cpp, line 36. Okay, so this is the Path2D constructor in libweb. And I guess, so a Path2D is it's like a path object that you can use together with your canvas element in JavaScript. If you want to make like a complex vector graphics path, and then like you want to save the path somewhere, and then you can sort of render the same path again and again without having to reconstruct the path every time. And I guess this to-do says that we should be able to construct these from an SVG path attribute string or path element D attribute string or whatever those are called. So yeah, so here it says FIXME for let SVG path be the result of parsing and interpreting path according to SVG2's rules for path data. Okay, so I know we have an SVG path parser because we do support the SVG path element. Parse. Right, so if the attribute D comes in, then we call attribute parser parse path data, save that in m instructions, which is a vector of path instruction, which has type absolute and data. So I'm guessing, right, so it's storing the SVG path in a little bit of a clunky way, but like certainly good enough that we can reuse this. I'm just thinking, like, how would I have written this in Yacht? And obviously, it would have been an enum in a language with, with nicer sum types. So, but anyway, that's not what we're here to do. We're here to, I guess, extract the path parser from the SVG path element attribute parser here, and then use that in Path2D. So I wonder if we have Path2D test. Here is an HTML file that has a Path2D going on. So let's build Ladybird so that we have it, and then we can test with this. Actually, I can probably use my current build because I don't think anybody has changed anything about Path2D recently. So what does this thing test? Oh, I have to say more specifically where the thing is. Okay, so taken from MDN. Should be a square and a circle both as outlines. I'm missing a little part of the circle here, but sure. And then SVG path example should display a filled black square, and that's completely missing. So maybe this is the exact thing that we're looking to test. SVG path example, get to 2D context, and then construct a Path2D object from an SVG path string. So this test actually has us covered. I feel like it's probably not meant to look this way. Can we take a look here with Firefox? Right, so it's a little bit of an issue here with this one, but that's not really what we're here to fix. We are here to, I guess, make this thing show up at all. So let's see if we can take care of this FIXME that we got. So, okay, we have our test. Did we get a new build? Oh, it's working on it. Okay, so, right, let's make sure that we're looking at the latest version of the spec steps as well. But I feel like this is going to be fairly straightforward. We just need to take the SVG path parser, extract that out so it's reusable. Maybe it's already reusable, actually. Wait. I mean, it is in a file of its own. It's just the name is weird because it's called attribute parser, and it's specifically a path attribute parser or a path parser. So maybe the right thing to do here is to rename it, because obviously it doesn't parse attributes like any attribute. It parses specifically one attribute. So it's a path parser. So let's go ahead and rename this attribute parser. Wait, am I wrong about this? Oh, I am wrong about this. Okay, my bad. It does parse more than just a path attribute. Okay, fair enough. Then we don't need to change the name. Okay, fine. Good. It says attribute parser, SVG attribute parser parse path data. And then what is the API of this thing for adding stuff? No API. Inherits canvas path. All right, so it has these APIs. Right, so I'm thinking we parse the attribute and we get those path instruction objects, and then we loop through them. And depending on the instruction, we perform the appropriate sort of path operation here. So Path2D. What if step 1, include libweb SVG attribute parser. Step 2, before I forget, share credit with Sam, who did the first part of the implementation here. Okay. Right, so SVG path is the result of parsing and interpreting. Is SVG path a kind of object, I wonder? Or is it more like a spec concept? Because path element is a thing. We should probably look at the SVG2 spec, path data. Yeah, blah, blah, blah. But there isn't like, there's a path element, but it doesn't have like a path object that you can get from it, right? If anything, you would expect it might have like a Path2D getter or something like that. But no. Okay. So let's see here what we do. So path instructions, SVG attribute parser, parse path data. Do we have a string? I guess this thing right here is a string. So path has, okay, so it doesn't have a Path2D. Then the path data is path get string. Okay. And then, let's see. Then we want to parse that path data. Path data, sure. And then path instructions. Okay, so now we're going to walk these, and we switch on instruction dot type. And it can be one of these. So let's copy those over. Okay. What were they called? Path instruction type. So time for a little multi-cursor action. Path instruction type. Case break click. Okay, so we shouldn't have any invalid ones, I guess. I mean, you can throw invalid data at this thing. You just put garbage into the input. So if that happens, will we put invalid into the stream? Parse draw to. Do we generate invalid in the parser? It seems like we don't. So I don't know why that thing is even there. Path instruction invalid. Nothing found. Wait, didn't I just type that here? Oh, path instruction type, sorry. Last instruction invalid. Seems like it's used as a sort of a sentinel value here or something like that, or kind of an optional empty thingy, but I don't think it will show up in the path that comes out of the parser. So this should not happen, based on my reading, at least, of that cursory reading of the code. Okay, so we get a move. What do we do when we get a move? Well, wait, probably there's somebody else who already does this. Let's see, case. Aha, here is code that SVG path element get path. Right, so this turns a vector of instructions, presumably, into a path. So we don't want to rewrite this code, actually. Because what if we could just take this code, turn it into a path thing? Would that work? Canvas path. Canvas path is a graphics path underneath. Right. And these things just call through on that. Right. So if we were to just do exactly what the SVG path thing does, and then just assign over the underlying path, I think that would be okay too. Yeah, so maybe we just need to yoink this thing out of SVG path element and make it be something more like, let's see, mpath is path from path instructions or something like that. Instructions. So we'll say here, like, if path does not have value, then we parse it and then return it. Yeah, something like that. Seems fair. And then path from path instructions. Okay. And then we just need a span of path instruction here, I think. Doesn't necessarily need to be a vector. And return path. Previous control point. I wonder why it's using a member for that. Seems like something that could be a local, hopefully. Previous control point. Let's see if that can be a local. Okay. So that will just be a local in the path parsing algorithms. All right. And we walk instructions. Previous control point. Wait, what are you mad about? Oh, I called it M. Right. And I think this could be an optional instead. Although, would that make a huge mess, I wonder? We don't have to mess with it right now. But, yeah, M path. Okay, so we got that factored out. We just need to make it accessible from the outside. Maybe we just do this to start with. Yeah, and then we can call that from Path2D. So we don't need to walk the instructions here, actually. We can just say path is SVG path from. I guess I need to include SVG path element for that. Path from path instructions. Redefinition of path. Oh, path is the input here. Right. SVG path then. Sure. So maybe we can streamline this whole process a little bit. Okay, and then let XY be the last point in SVG path. How do I get the last point? Segments dot last point, I guess. Wait, what if it doesn't have a last point though? So I guess if you have a completely empty path string, then if SVG path is, can it be empty or something? So if we have some kind of segments, let's say, add all these subpaths, if any, from SVG path to output. Okay. Yeah, we'll just do all of these steps here if there are any segments in the path. And then this path equal SVG path. I think that's what I wanted us to do, right? And then create a new subpath with XY as the only point in the subpath. What does it mean to create a new subpath in this context? Create a new subpath. I guess we move to. As I recall, move to is the way to create a new subpath. Yes, move to is create a new subpath with given point. So they're just telling us to move to. Move to X, Y, X, X, Y, Y. Yeah, and then return output. This is effectively like just letting the constructor finish, right? So that's okay. Let's see if this would work. Not quite. Oh, wait, did I not? No, I was just seeing the to-do here, implement constructing Path2D object. But that's okay. Okay, so it doesn't quite work. Let's see. Can we debug line the path? I wonder how that works. Parsed path. I don't know if we have a path printer. That would have been too easy, right? Path. Oh, it has 2 string. All right. So maybe that should just be hooked up with the debug line. So what do we get here? Parsed path. Okay, so it has parsed the path. I guess we can look at the path to see if it sort of matches up. Move to 1010, line to 9010. What are we looking at here? Move to 1010. Horizontal line to 80. I guess those are relative coordinates. And here we're looking at absolute coordinates. Vertical to 80, relative, so that, wait, does that make sense? I'm not sure. Does line 2 not move the cursor? Or is it that it's, wait, it's minus 80, so maybe I'm looking at the wrong thing. So it's like going 80 pixels to the left. And then Z to close the path back to the beginning. It looks vaguely right, but it doesn't paint anything. So why doesn't it paint? Let's see. We do have some extra output here, like unable to determine type, unable to determine category for type name Path2D, assuming it's an interface type. Okay, and then unrecognized fill rule for CRC2D fill. The problem goes away once we pass an enum instead of a string. Unrecognized fill rule. Okay. Is there a default value to this thing? It'd be nice if we could see what the unrecognized rule is. So let's print it out. Because the first error where it's like assuming something, that seems vaguely okay. Unrecognized fill rule object. Okay, well that seems not great. Maybe we should actually look at what the fill rule is for this thing. Fill P. Oh, do we just not implement fill with a, wait, why are we here with an object in the fill rule string? That's really weird. So it should be this API right here. Canvas 2D IDL. Let's see what it says. Fill. I guess that's part of, I don't even know. Canvas path, maybe? No, Canvas draw path, maybe. Fill. Okay. DOM string should be canvas fill rule. Oh, are we taking this instead of this? I wonder, like if we're picking the wrong overload maybe. Because if we're picking this overload, then we've stringified our thing, we've stringified our Path2D object, and it just says object. And then we're passing it to the fill rule here, and we should be taking this overload. Why are we not taking this overload? Maybe it's a bug in overload resolution. I think we're probably gonna have to fix that. Okay, so where do we look for this stuff? Let's verify that we're taking the wrong overload first of all. So first thing, I mean, we are probably, but let's double check it. Fill. So we should be in this guy that takes a Path2D. Fill string just gonna log this or fill Path2D string. Oh, look, it's fill string. Great. So let's get rid of that debug line. Okay, so far, we can probably commit the code that just parses the path and stuff. So actually, let me verify also that I didn't break SVG paths. Okay, this page still looks beautiful as ever. So we didn't break SVG paths by factoring out the parsing. So that's okay. That's good. So here, let's just say libweb factor out SVG path parsing from SVG path element. Parsing is converting a vector path instruction is now done by a free function so that we can share this code with HTML Path2D. Okay, and then I think I'm okay with just committing the Path2D change as well. Parse SVG path support creating Path2D objects from SVG path strings. Yes. This reuses the SVG path parsing code. Okay, so these fellas, what's going on with these fellas? So I just want to edit the test a tiny bit to see if we can console log something interesting about that thing. So path, what was it called? Path, canvas, Path2D, right. So if we log that p fella, what does it think it is? Also, I am losing myself in my terminals here, so let's have a fewer of those. Wrong file. Okay, blah, blah, blah. JS log, object Path2D. That's kind of curious that we're taking the fill string overload, which is wrong. It's the wrong overload. And then the fill rule that gets passed to it says object object after stringification. But when we stringify by passing it to console log, it says object Path2D. So these are not even the same object, I think. So that's a bit weird. So maybe we should look at unable to determine category for type and see. Unable to determine category for type named Path2D. How do we determine categories? Libideal types. What is this stuff? Distinguishability category? Interface like, see below. So right now we just assume everything that we don't recognize as one of the above things is an interface. But the thing is, it's correct that it is an interface. So the assumption is fine. Path2D is an interface, as far as I know. Interface Path2D, right? There's an interface that includes canvas path, but it is an interface. So, so when do we decide which overload to take, I wonder? Maybe we should read the bindings code, because I haven't looked at the binding stuff since overload resolution was implemented. Or at least since the current iteration of overload resolution was implemented. So canvas rendering context 2D prototype CPP. Yeah, that's what I want to look at. All right, so I'm calling Phil. Phil, where are you, Phil? Okay, so there's Phil 0 and Phil 1. Okay, Phil 1 is the one we want to end up in because it knows about Path2D. And here is Phil. This is where the overload resolution is supposed to happen. Okay. So we make an effective overload set. Oh, we're switching on the argument count. Interesting. So if the argument count is 0, then trying to understand how to read this. Argument count, min of 2 and argument count. Min of 2 and argument count? Wait, that's weird. Then how would we get these? Because it's the smaller of 2 or argument count. So if argument is, oh wait, I'm stupid. If argument count is 0, then it will be 0. I'm mixing up min with max. The smaller of 2 and argument count. Right. So how many arguments were we passing in our case? It's not the right file. We were passing a single argument, just the p. So we would be here in the 1 case. Okay, so overloads. So this means that there are 2 overloads to choose from. Either the one that starts with a DOM string or the one that starts with a Path2D. All right. And the DOM string is optional, but the Path2D is required. Okay. So our overload set has 2 possible choices. Okay. And then what do we do? If we don't have an overload set, we do, that's fine. And then we have to resolve overload, whatever that is. So we call resolve overload with the effective overload set. And that gives us a callable ID, either 0 or 1. So I guess let's look at what resolve overload does. Resolve overloads, and it has a spec link. Fantastique. Okay. Wow, this is quite the involved algorithm. It definitely feels like something that there's it looks pretty heavy what we're doing here. Like building this overload set, which has heap allocations and stuff going on. So it means that just calling an API that has overloads is like pretty heavy in our overload resolution code. And it seems like something where we can avoid heap allocations, and also probably something where like once we've resolved it the one time, then it's always going to resolve to the same thing. So it's probably something that could be cached. Anyway, I'm thinking too far ahead. That's definitely not what we care about today. So resolve overload. Okay, bunch of steps. So how is this supposed to work? So we want to find, oh my goodness, that's a long algorithm. How many steps are there? 17. 17 is incidentally, it's like a curse word in Swedish. One of the mildest curse words that we have. Swedish profanity. 17. 17, as we say. 17 också. Anyway, getting totally off track. So there are 17 steps to this. Or wait, were they 17 sub-steps to step 12? No, 17 total steps. Okay. So I have my effective overload set, and I want to find that we should be calling the second one, because the second one is a Path2D object. And my input is a Path2D object. So let's just walk through this thing here without verifying the code. So let's see. If overload's size is greater than 1, yes. That should be a thing because we had 2, right? Where was the thing I was looking at? Here. So we have 2 overloads. These 2, the DOM string based one and the Path2D based one. It's interesting that the overload set like has the one type. Like shouldn't, or am I thinking wrong about this? I feel like it should have like the Path2D and the string, because there's a string argument to the Path2D overload as well. Although it is optional, so maybe it's they only put it there if it's not optional. Or is this what this last thing is here? Oh, if it's 2 arguments, then it's only one possible overload, and it's this one, where Path2D and string. I see. So it's because we're passing one argument, then this is the overload set. Okay, well that makes sense. That makes sense. So what is our distinguishing argument index, and how do I even know what that means? The distinguishing argument index seems like something we should look up. If there's more than one item in an effective overload set that has a given type list size, then for those items there must be an index I such that for each pair of items, the types at I are distinguishable. The lowest such index is termed the distinguishing argument index for the items of the effective overload set with the given type list size. So I think that should be 0, right? It should be 0 because it's distinguishable on the first type, because it's string or Path2D. So let's see. Yeah, let's print out what the distinguishing argument index is. Disting arg ind. I just want to see that we are on track here with this thinking. Disting arg ind is 1 for the fill call, or 0, sorry. Yeah, so 0th argument, the first argument. Okay, so far so good. So the 0th argument is distinguishing. Okay. While I is less than the disting arg ind. Okay, so D is the distinguishing argument index. So while I is less than that, so we will skip over all of this. If I equals D, yes, we should be at the distinguishing argument index at this point, so we should be here. Then let V be args I, so presumably args is the arguments being passed. Let's see. What is args in this case? Args. ECMAScript values. A list of ECMAScript values, args. Sure. Okay, so we know that the 0th argument is a Path2D object. So it says if v is undefined, that's not the case. Otherwise, if v is null or undefined, should not be the case either. Otherwise, if v is a platform object, ooh, it should be a platform object. It is an object. Is it a platform object? Let's look at our Path2D. Are you a platform object? You are a platform object. Okay. So what do we say about that here? So if it's an object and it's a platform object and it has overload with argument type or subtype matching overloads I, let's see. FIXME, an interface type that v implements. So it seems like here we just check. This is like a FIXME about that, but this is not the FIXME that we're here for, but it's checking, as I read it, is there any JavaScript object in the argument slot? Wonder what this function does. Has overload with argument type or subtype matching. It's strange that this is a mutable overload set. Does it really want to be mutable, I wonder? Has overload. Why aren't these things const, I wonder? Oh, because it's caching something. Caching last matching item. Okay, okay. Fine. I don't know. Maybe that wants to be mutable. Who knows? It seems weird that you would ask these kind of questions. And that also seems like it could be part of an output tuple or an out param or something like that instead of storing it in the effective overload set. Anyway, it's so easy to get sidetracked, but let's not. Okay, so has overload with argument type or subtype matching. I feel like we should be matching in this case, and we're probably not. So has overload with matching argument at index. And what's the index we're looking at? Argument index. Let's see, overloads I. So we would be passing in 0 and then this matching function here. So let's see if we're being asked about anything. Ask to match arg for whatever. So let's just print out here I and type. Oh, IDL type. I wonder what that is. Name, I guess. Let's capture I. I just want to see what it says. What name we think that we found there. Ask to match arg0 for DOM string, which it isn't, and then ask to match it for Path2D, which it should be. True. False. Let's see. Let's see. Both are false. Okay, so neither of them are considered to be object for whatever reason. Right, because they're not just object. Wait, okay, so that's why it's rejecting it, because it's not. The object type corresponds to the set of all possible non-null object references. So the IDL type, so it knows its name. It knows that the name is 2D. What are they asking here? Like, is plain? What does plain mean? Kind plain. Okay. So, name. So should these be considered objects? I mean, I feel like it should be, but regardless, what we should be really checking here is the name, right? The name of the interface. An interface type that V implements. So V is value. So if the type of value, the class name for value matches the IDL type that we see here. So our value is, let's see. The JavaScript engine has the IDL type we're trying to match is Let's see what we can print out here. So value, how do we get to it? Value as object, class name. Like, I don't know that we have like, if we stash anywhere, JS path, okay. So we do stash the exact name that we need. That's what I was thinking. Like, if Path2D's class name matches the IDL name, which I think it always will. So it's a platform object that has the same name as the thing that we're looking for. I think that would be okay. I think. So let's see. An interface type that V implements. So it's one of them. Right. So here, let's just say if type name is value dot as object dot class name. Turn true. Right? Then we don't need to capture I here. Crashed. Okay. Where did we crash? Effective overload set only item. Okay, well, we're gonna have to move forward here. So resolve overload 365. So presumably we finish here. And I'm just gonna why does this indent so weirdly? Okay. So we go through here. Now we say, yes, we have an argument with an argument type or subtype matching this. Yes, we do. Then what we do is remove all other entries. So now we've picked that one entry that we like. And then we carry on. It's not an array buffer. It doesn't have a data view internal slot, not a typed array, whatever. Path2D is not a callback function or whatever this is looking for, I guess. It's not any kind of array, blah, blah, blah. So we should be just blowing through here because we already found the type and these are all else ifs. So where does it bottom out? Okay, we don't get here. We're down here. What was it? 365? 365. Only item. Oh, this is the call right here that's failing. let callable be the operation of extended attribute, operation or extended attribute of a single entry in S. So there should only be one, because we call that remove all other entries thing, right? So item count is how many exactly? Overloads dot size. Item count is 0. Well, how did that work out? Remove all other entries. Remove all matching. So everything where item is not the last matching item. Interesting. So what does that mean that we do? All except M last matching item. All right. Wait, what? Oh, it's a pointer. Okay, sure. Last matching item. So it should have been set here. Like we should have said, oh, this matches. Because this weird algorithm was supposed to set that thing, right? If matches, then set that thing to the thing, sure. And it is a pointer. Removing all except. Okay, I'm suspicious of this removing all except thing. Where was that code? Here. From n entries, removing all except items size. Let's see how many we're actually removing from here, because from 2 entries, removing all except, and then we have 0 remaining. What? Oh, wait, is it because none of them are? If none of them are M last matching item, then we will remove all of them, right? Let's see. So let's dump out all the entries. Let's see. Entry. And then entry is M last matching item. If so, just print something so we see that that's the one that we're supposed to remove. From 2 entries, removing all except this. So we shouldn't be removing this. What on earth? After remove all matching. How many entries? What's going wrong here? After remove all matching have 0. Oh, come on. Remove all matching. Wait. It's removing based on a pointer. And if you have a pointer to the first element in the vector, and then you remove the first element in the vector, then the second element of the vector now has the same address as the first one. So you'll keep removing the first one because you're doing it based on a pointer. Yeah, that's not gonna work. That's such a goofy bug. Okay, so yeah, that's definitely a problem here. So we're nuking it based on the pointer address. We should really be nuking it based on the index. So we should remove all. What is an easier way to do this? I guess to just take the matching item. So what is items? It's a vector of item, right? So vector of item, new items. New items append m last matching item. What does an item have? Some things, whatever. And then we'll just do this. Okay, don't want to lose that. Right. Wait, it worked. I wasn't paying attention. It works. Cool. Wait, did I not need, because now I just got to double check if I actually needed that first change. I feel like I still needed that first change. Type name. Yeah, I still needed that first change. Right. Yeah, so that's such a funny bug that you're trying to remove everything from a vector that has the address of one of the elements. And the first element also. Okay, so last matching item. Yeah, I think we could also, like, there are many different approaches here, right? But it seems to me like using a pointer into the vector, it's never a great idea, no matter what. It's always better to use an index. So let's switch that to using an index, just so we don't need to foot shoot ourselves. And here we just store index, right? And then here, I think like going through the vector with remove all matching, it's still way less efficient than just like making it a new vector and just substituting it, because going through the vector, you're sort of deleting one element at a time, and every time you delete an element, you have to shift the remaining elements in the vector. So that's not great. Although this will heap allocate. I don't know. I mean, if this thing were to be a bottleneck, what we would do here is we would just put some like inline capacity on it or whatever, and then it wouldn't heap allocate anyway. But let's not micro optimize things that are not known bottlenecks or issues. So for now, we will just do, can we take an item at an index? Although that will cause a move, so we don't need to do that. Just do that. Right? Okay, and did we have any other uses of this? I don't think so. Wait, you have to rebuild the entire world because of what I did now? Oh, no, okay, it's okay. It's not that much of the whole world. Some, but not all. Okay, so git checkout. Don't need that change. Last matching item. Can get rid of that debug log change I got there. Yes, okay, so libidl. Libidl. Wait, now it doesn't work again. Dang it. How did I mess that up? M last matching item equal, I said index. But that's not the index I should be using. It should be the index into M items. Right. Right. I messed that up. We'll fix it. I. Items I. Yes. That's pretty good. Can it be Kunst? It can. Cool. Okay, so we will say, okay, so what was this commit gonna say? Don't prune, or let's see, don't fix bug where entire overload set was erased or erased. That's what this thing is called, effective overload set. Yeah. Yes, that's great. Okay, so there was a funny bug here. What was it called? Last matching item. Storing the last matched item as a pointer. And then using vector remove all matching to remove all items not matching that, all items that didn't have that exact address. Everything after the last matched item got removed as well. Where since this happened because every time an element or an item moved from the vector, remaining contents shift one step towards the start of the vector. Changing everything's address, or affecting addresses. Okay, so in cases where the the first zeroth item was the last one matched, we'd delete everything in the effective overload set. This patch fixes the issue by storing the last match as an index. Cool. And then we also teach the overload resolution algorithm to look at the class name of the value being passed. So we don't need that second hunk there. Okay, libweb. Consider the match platform object class names against IDL interface names. Or it's more like a implementation detail description. fix overload, web IDL overload resolution. With interface arguments, or with platform object arguments. Yeah. We now match the class name of platform object arguments of platform objects against ideal type names when resolving web IDL overloads. This makes canvas rendering context 2D .fill Path2D. This makes passing a Path2D object to this function actually choose the Path2D overload. Cool. That's pretty cool. It works. It's so neat. So started out with that one FIXME about constructing the Path2D object from an SVG path string, and then we ended up fixing another FIXME in the IDL overload resolution algorithm, I guess. So grep FIXME, or wait, FIXME. Oh, we deleted so many FIXMEs. Were there any to-dos? Yes, we also got rid of a to-do. Wow, look at that. Wait, what was that FIXME in the... wasn't there a FIXME in the overload resolution file? Class name. Here, an interface type that V implements. Oh, it was this one. Yeah, right. So 1, 2, 3, 4, 5, 6, 7. 7 FIXMEs and to-dos. Man, that's quite a haul. I am very pleased with this. And yes, that circle is off to the right where it shouldn't be, but I will leave that for our future selves or anybody else who feels like they would like to investigate. You are now encouraged. So this will be the end of today's video. If you made it this far, thank you so much for watching, for hanging out. I hope that you saw something interesting. I certainly enjoyed getting this up and working, and also learning a little bit about the IDL overload resolution algorithm, because I hadn't really messed around with it before. So it was nice to become a little bit more familiar with it, with our implementation of it. So cool. Thanks for hanging out, and I will see you all next time. Bye.